In this video, we're going to talk about the monopolist profit maximization problem, and we'll see how their production decision as a price setter differs from that of a price-taking firm. So, under perfect competition, we said that all firms were very small, too small to affect the market. What that meant was that the price was determined in the market overall, and each firm took that as given, so that at that price, they could sell any quantity they wanted. However, if they were to try to sell to charge even a little bit above the market price, they couldn't sell anything. That's why we said that firms under perfect competition were price takers. So they take the price as given. In that case, suppose that you're currently producing at this quantity level and you're wondering, well, should I produce more or less or stay here? What is the firm going to consider? Well, if it produces one more unit, it will be able to sell it at the market price, right? And the cost of making it is given by marginal cost curve. So that means that their profits will increase because their revenues will increase by more than their costs. And so that means they should produce the next unit and also the unit after that until we're at the intersection between demand, elastic and perfectly elastic at the market price, and their marginal cost. And so this is the optimal production level for a price-taking firm. The reason, again, is that their marginal revenue, so their increase in revenue, anytime they produce one more unit, is simply equal to the market price. Okay? So the point where they maximize their total profits, so where marginal revenue equals marginal cost, will be where marginal cost equals the market price. What about a price-setting firm? The key distinction between a price setter as opposed to a price taker is that they face downward sloping demand curve. So the price in the market is not externally given. You could see how if they choose to produce this quantity, then they can charge this price. However, if, for example, they chose to produce more, they would have to charge a lower price. If they produced less, they would be able to charge a higher price. So because the price at which they sell their goods is directly influenced by their quantity supplied, we say that the firm has the capacity to set price. So suppose that they're currently producing at this quantity. Let's just start at some random level the way we did here. Now, what should the firm consider? If it produces one more unit, it will be able to charge a price for it that's a little lower than the current price, but that is still above the marginal cost. So that would increase their profits. However, now they have to worry about all of the other units they've sold as well. If we think that the firm is constrained to charging the same price from everyone, so it's a single price monopolist, then when they're lowering their price in order to sell more units, they're lowering their price for all of the units they sell. So although we have a positive gain here, okay, let's say that they increased their quantity sold to this new level. And so here we're still having positive extra profits. What's also happening is that the price at which they're able to sell these goods is now lower. And so for all of those units, they're losing money. So although the price in the market at that output level is above marginal cost, their increase in revenue when they produce more is actually below marginal cost. Because the firm is facing downward sloping demand, the revenues increase from producing one more unit will be less than the market price. As we've already argued, because profit is the difference between total revenue and total cost, the firm will want to keep producing more as long as marginal revenue is greater than marginal cost. So as long as the increase to revenue from one extra unit is greater than the increase to cost from one extra unit. In this case, what is marginal revenue? We might be tempted to think that marginal revenue is the price at which they can sell the next unit, but recall that's not the whole story, because in addition to that extra price, they have to suffer the loss from charging less for all the other units. The best way to correctly find the marginal revenue is to introduce also a total revenue column that will limit mistakes. So what is the firm's total revenue when they sell a single unit? If they're only selling one, they can charge $10 for it, so a total revenue of 10. If they're selling two, they can charge 9, so 2 times 9 is 18. They're selling 3, they can charge 8, so we have 24 here. 4 times 7 is 28. 5 times 6 is 30. 5 times 6 again is 30. And 28. Marginal revenue, now we could easily calculate it as, for the first unit, it's just the price at which they sell that unit, so that's 10. However, for the second, it's the difference between total revenue when selling 2 units, so 18, minus revenue when selling a single unit. So that'll be 8. 24 minus 8 is 6. 4, 2, 0, minus 2. And so then we would continue with lower negative numbers. So if we look at this more closely, we're comparing marginal revenue with inverse demand. You could see that they start at the same price. So for the first unit, marginal revenue is the same as the willingness to pay for that of the first consumer. However, marginal revenue drops at twice the rate of inverse demand. Okay, so if we were to draw marginal revenue on this graph, which we can do because marginal revenue, just like inverse demand, is measured in dollars per unit and is a function of quantity, it would start at the same intersection as demand, but it would drop at twice the rate. So the slope would be twice as steep. This would be our marginal revenue. And so this firm, like any other firm, continues to produce as long as marginal revenue exceeds marginal cost. That means that they'll stop producing at the intersection between marginal revenue and marginal cost. So in our chart here, we're going to look at the marginal revenue versus marginal cost columns. So as you could see, as we go, we have that for that first unit, the increase in profit from selling it is $9. From the second unit, it's $6, $3, 0. So the fourth unit is where already we have that marginal cost equals marginal revenue. And so that's where we will stop production. Okay, even though, as you could see, at that level, we still have that for the next unit, a consumer is willing to pay $6, whereas it only cost the firm $5 to make it. So we're not going to produce all the units where marginal benefit exceeds marginal cost. We're going to stop short of that if we have price setting power. Let's look a little more closely at this graph. So we said that if we have linear demand, then the firm's marginal revenue is also linear. It starts at the same intersection with the y-axis, but it drops twice as fast, and so it will intersect the horizontal axis at halfway the distance to the intersection of demand. After that, it will be negative, but we are not particularly interested in that region. So the firm will then produce as long as marginal revenue is above marginal cost, and we'll choose to produce this quantity. We could say this is Q monopolist, QM. What price will they set? At this quantity, the cost for producing that last unit is given by the marginal cost curve. However, they don't have to charge at marginal cost. They're going to charge the highest price that consumers are willing to pay at that quantity. So monopoly price is given here. If that's the case, then let's analyze welfare in this market. So how much surplus is generated and who does it go to? First, consumers. Consumers buy QM units at price PM, so their surplus is given by this small triangle. What about the monopolist, the producer? Well, they're selling QM units and selling each at PM, so their surplus from producing will be this trapezoid. And this surplus is no longer realized. This is now deadweight loss. So in this graph, as we have it here, with demand, marginal cost, marginal revenue, we could show producer's surplus, right? That's this area. In order to show profit, we need to take into account the fixed cost as well. We could do that by drawing the average total cost curve in the graph. Suppose that average total cost is very high because there's a very large fixed cost. Suppose that this is either a very small market or a market with sizable needed investments. And so average total cost starts very high and decreases relatively slowly, intersects marginal cost, and then begins to increase as well. If this is our average total cost, then what will the firm's profit be? Well, we're simply going to ask at the quantity that the firm is producing, what are average costs? And so here we see that the average cost is above the price that the monopolist can charge. So this would be a case where the monopolist's profit is actually negative. Now suppose that the fixed cost is smaller, so that average total cost dips under the demand curve. Again, it will intersect marginal cost at its minimum value. If things look like this, then at the monopoly quantity, the average cost per unit is marked here and is below the price that the monopolist can charge. So in this case, the monopolist would earn positive profits. But they would still not be as high as producer's surplus.